Hi guys, it's Mrs. Millison. Okay, today we're going to learn about sampling. Um, this is Unit 3, Chapter 4, and Section 4.1. So sampling, the good, the bad, and the ugly. Okay, let's first talk about why we sample. Okay, we we want to know something about a population. Okay, I don't know, maybe the percent of people that wear glasses or contact lenses. Okay, that's not published anywhere. I don't know it. So I've got to find that information out. So I could do one of two things. There's my population. I could ask the whole population, or I could take a sample, which is a subset of the population. Now, if I ask the whole population if they wear glasses or contacts, that would be a census. Okay, yeah, that's not going to happen. My population might be too big, and I'll give some examples of population and samples. By just taking a sample and asking them if they wear contacts or glasses, it's more time and cost efficient. Okay, so if I do sample properly, and I'll talk about proper ways to sample, whatever comes from my sample, I can infer back to my population. Okay, so let's say my population is, and a population can be any larger group. Okay, everybody says population, you think about all the people in the world. Well, anything can be a population. Any group that you want to find information about. All the people that live in Charlestown can be a population. All the people that go to our school can be a population. So if I want to know something about a specific population, I can take a sample. Just more time and cost efficient. So what I do is I take a sample. Let's say our population is all the students at school. What do we have, like 1,600 students? So I'm not going to ask 15 or 1,600 kids whether they wear glasses or contacts. So I'm going to take a sample, say 50 students, okay? And I ask them if they wear glasses. And I get a statistic. So I get, 20 out of 50, okay? So 20 out of 50 is like 40%. So from that sample, I can infer the population parameter. I can infer that 40% of my population wears glasses or contacts, okay? Now, we'll talk about how a sample statistic will be different every time, and that's fine, and we'll see that later on, okay? So before we talk about the good ways of sampling, let's talk about the bad ways of sampling. Okay, one bad way is convenience sampling. And convenience sampling is just accessing people for your sample or subjects for your sample that are nearby and easy to access. So if I was going to ask students at our school if they wear contacts or glasses, maybe I'll just ask my students. Okay, I see them every day or every other day, and you're easy to access, and I'll just ask you a question. You wear glasses or contacts? But you all really don't represent the whole population. Most of you are juniors and seniors, so my freshmen aren't represented. Maybe a few sophomores would be represented, but I'm not getting I'm not getting a good representation of my population. So that's why it makes convenience. That's why convenience is not a good sampling method. Okay, because my sample will not represent the population. Another one is voluntary sampling. This is where I ask people to participate. So things like on the internet, when you see those little surveys that pop up, if people are going to self-select to participate in the survey, then that's not a good sampling method, okay? Because people that are going to volunteer to answer questions or be part of a survey usually have a very strong opinion about the topic, or they want to participate. Most people that are happy with the status quo, happy with the way things are, usually won't participate in those types of voluntary surveys. Okay, so why are these bad? Okay, first of all, the sample that results from convenience or voluntary sampling don't represent the population. Okay, some group might be left out or something like that, and I'll talk about that too in a second. And the reason they're bad is because there's no randomness in the selection of the sample. Okay, randomness is very important. And if there's no randomness and the sample doesn't represent the population, then bias can be introduced. Okay, and biased is when the results of your survey over or underestimate the population parameter that you're trying to find. Okay, so if I stood outside an eye doctor office and asked people wear glasses or contacts, of course my proportion is going to be really high, and that's going to be an overestimate of the true proportion of people in the population that wear glasses. Okay. And of course, if I do a voluntary survey, perhaps people that wear glasses or contacts will volunteer to answer the survey because they're like, yeah, hey, I wear them. So again, that'll probably be an overestimate of the true percentage of people that wear glasses or contacts. Okay. All right. Oh, here we go. Why they're bad. Samples don't represent the population. There's no randomness in selecting the sample, and bias will end up with a biased estimate. Okay. All right, so let's talk about good ways of sampling. Now, good ways of sampling involve randomness, okay? The first way is called an SRS, or a simple random sample. This is where we would put, say we were gonna survey the school. I would put everybody's name on a piece of paper and stick it in a big hat and mix up the hat and just grab 50 names out of the hat, okay? In an SRS, all samples of a specific size have the same chance of being selected. So every group of 50 people have the same chance of being selected by pulling those 50 names out of the hat, okay? And we'll talk about how opposed to the other type. There's another one called stratified random sample, again, all involving randomness, where we divide our population into homogeneous groups called strata that have a similar characteristic. And then we just select a few subjects from each strata. So for our school, for example, we would divide our population of students into maybe freshmen, sophomore, juniors, and seniors. And I would go and select maybe 12 freshmen, 13 sophomores, 12 juniors, 13 seniors. And then I would have my sample size of 50, and I'd have a good representation of my student body, because there would be no group that was left out. Okay, no group of a characteristic that was left out. So that's a stratified random sample. A cluster sampling is when we also divide the population into groups, but these are heterogeneous groups. So each group is sort of like a little mini population, and it has all the characteristics of the population, okay? And then I would just select a few groups. So for example, for school, I might use our hallways as clusters. So hallways A, B, C, and D. So at any given moment when we're all in school, there should be freshmen, sophomore, juniors, and seniors in every single hall, okay? So if I randomly selected one hall, we'll say C hallway, and then I use everybody in that hallway for my sample. So that's cluster sampling. The last way is systematic sampling. Now, systematic sampling is where I would select every nth subject from a population. And my favorite example for this is, say an airline wants to survey their customers. Well, an airline is not going to send a survey to every single one of their customers. They get too many customers. So they're going to maybe randomly select an airport, okay? And then they're going to randomly select a day. And then on that randomly selected day, that randomly selected airport, they're going to ask the flight attendants, so everybody flying on that airline for the day, every, say, 10th person that gets on every flight, hand them a survey, okay? So every 10th person when you get on the plane will be given a survey. So that will provide them with a nice random sample, okay? So that's every nth subject. Okay, one of my favorite examples on how to differentiate between stratified random sampling and cluster sampling is to think about a Boston cream pie. Okay, you know, a Boston cream pie looks like the picture on the right, sort of. It's got cake and then a layer of cream and a layer of cake and then chocolate, okay? So for a stratified random sample, I would divide the chocolate, the cake, and the cream out. And then I would take a little bit of chocolate and a little bit of cake and a little bit of cream from each group, and then that would become my sample. So that's my stratified. So the chocolate, the cake, and the cream of strata, and then I SRS a little bit of chocolate, a little bit of cake, and a little bit of cream out of each group, and then those little bits of pieces become my sample, because then I have every part represented, every subgroup in my population represented. The cluster sample would be if I took my cake and I sliced it into a whole bunch of pieces. Okay, say I slice this cake into 10 pieces, and then I randomly select one piece and perhaps a second piece. Okay, so then these two pieces become my sample, because I'm going to use all of the parts of these two pieces. So in these two pieces, I have chocolate, cream, and cake. So both my samples whether I stratified or clustered them, have a little bit of chocolate, a little bit of cream, and a little bit of cake. So the population of the greater Boston cream pie is represented in both these samples. Okay? All right. Now, why are those 3 or 4 ways of sampling good? Well, randomness is key. In convenience and voluntary, there was no randomness. So in SRS, cluster, stratify, and systematic, there is randomness, okay? And sample size is also important. Larger the sample is always better. Okay, so where do we see our randomness? In an SRS, in a simple random sample, we randomly select our sample. So we would put all the names in the hat and we would just randomly pick them out, okay? And I'm going to do another video on how to do an SRS using your calculator and a random digit table, okay? In a stratified random sample, we randomly select a few items from each group in a stratified sample. So again, if I divided our student body into freshmen, sophomore, juniors, and seniors, I would take all the freshmen's names and put them in a hat and then randomly select 12 freshmen. I put all the sophomore names in a hat and randomly select 13 sophomores and so forth. So that's where randomness is introduced there. In cluster sampling, when I divide my population into groups that are little mini populations, and again, like our hallways, we have 4 hallways, I would randomly select one. So I would randomly select A, B, C, or D. Maybe put A, B, C, and D on a piece of paper and put in a hat and randomly select one, okay? And then for systematic sampling, the randomness comes in to select whatever nth item I want. So for my airline example, I think I said the 10th person, the 10th passenger, every 10th person that comes onto the plane. Well, I would randomly select that number. So say I wanted to, say if I knew there were 100 people flying that day and I know I wanted 20 for my sample, I would have to randomly select the 5th person, every 5th person. Or if I wasn't sure how many were flying, I could just randomly select a number from 0 to 10, say 8, and then I would survey every 8th person. Okay, so there is some level of randomness. We don't pick what we want. Okay. All right, so we've got our bad ways of sampling, convenience and voluntary, our good ways of sampling, which are SRS, stratify, and cluster, and systematic. And the good is random, the bad is not. The good ways of sampling represent our population, the bad ways do not, our sample does not. However, even if I follow all the rules and I use my good ways of sampling and I incorporate randomness and I have a good sample size, sometimes some ugly can creep in. Sometimes I can have bias introduced without me having done anything, okay? So some ways that bias can be introduced is if our sample has undercoverage. Say there's a subgroup that was not represented, okay? So for example, if I did an SRS of the student body, so I just put everybody's name in a hat, all 1,600 kids, everybody's name in a hat, and randomly selected 50 students. Now, that group, that sample of 50 could conceivably be just sophomores, juniors, and seniors. There were no freshmen selected. So now my very well-picked random sample has undercoverage because the freshman class isn't selected, okay? Now, that wouldn't happen if I did a stratified sample. If I picked a few freshmen, a few sophomores, a few juniors, and a few seniors, I'm kind of taking care of that undercoverage. That undercoverage shouldn't exist, okay? Because in undercoverage, I couldn't get like all sophomores, juniors, and seniors, but in SRS, I could, okay? Another type of bias is non-response. So some of my sample can't be reached or they refuse to answer. So let's say I got my freshmen, sophomores, juniors, and seniors, my 50 student samples, and I send them a survey, and out of the 50 surveys I sent, only 30 return them, okay? So that's a non-response issue. So now my sample that was so carefully selected and nice and random, maybe out of those 20 people that didn't respond, they were all seniors. So, not getting a response from your sample or them refusing to answer can influence my results and make them biased. Another type of bias is called response bias. And this is when you survey people and they give you untruthful responses. They lie to you. You ask them a question and they lie. Or they're influenced by the person asking them a question. So say I'm a brunette and say I was going to survey 10 to or 50 people and ask them if they like blonde or brunette hair, what color they like better. Well, I'm brunette, so probably people are going to say brunette because I'm the one asking them. Okay, so then my proportion of people that like brunette hair is probably going to be higher than from my sample than it actually is in the population. So response bias can mess up the results. Okay, and then also another way of untruthful response is the person answering the survey tells the surveyor what they want to hear. So say a teacher surveys 50 students and says, did you do your homework last night? So of course the students are going to be like, yeah, I did my homework, okay, because a teacher's asking you. But if a friend asks you, you'd be like, nah, I didn't do my homework, okay? So you tell the interviewer, again, you're influenced by what the interviewer is saying, but you're also influenced by who the interviewer is, okay? So you're going to tell somebody what they want to hear. All right. The last type of bias that can be introduced is word of a question, how the question is worded. So it should be wording of a question. Sorry about that. Sometimes questions are worded to influence you to answer a certain way, or they're worded so confusing that you don't know how to respond. Okay. Sometimes they're worded with choices, A, B, C, D, E, F, G, H, and if there's too many choices, you get lost in the choices, and people tend to pick the first or the last choice. So sometimes the way the question is asked can lead to bias. Okay. So all of these, again, can unknowingly lead to bias, which again means your sample statistic will be an over or an underestimate of what the true population parameter is. Okay. Okay. So just to recap, we've got the good ways of sampling, SRS, stratified, cluster, and systematic. We've got the bad ways of sampling, convenience and voluntary. The most important thing is our sample must represent our population, and it must have randomness in it. That way we can infer the results of our sample statistic back to our larger population. And even though we might make the best efforts to get a nice random sample that has a good size, we might still have some bias in there from undercoverage, non-response, response, or wording of a question. Okay, I hope this was helpful. See y'all later.